In this short video, you will learn the fundamentals of writing promises to defer execution of your code. First, we will learn what a promise is and go through the 3 possible promise states in theory. You will then learn how to describe these state transitions in ES6 by creating and evaluating promises. You will find out how to handle the fulfilled state and the rejected state of your promises through examples. We will conclude this lesson with joining multiple promises and executing them in parallel. Promises represent the eventual result of an asynchronous operation. They give us a way to handle asynchronous processing in a more synchronous fashion. A promise represents a value we can handle in the future with the following guarantees. First of all, promises are immutable. They are either kept or broken. Whenever a promise is kept, we are guaranteed to receive a value. Whenever a promise is broken, we are guaranteed to receive the reason why the promise cannot be fulfilled. There are 3 possible promise states. Initially, promises are pending. A pending promise may transition into fulfilled or rejected states. The fulfilled state represents a kept promise. Kept promises have to have a value. The rejected state represents a broken promise. When a promise is broken, there is always a reason for rejection in the form of a JavaScript error. Creating a promise is easy. You can use the new promise constructor call and pass it a function with 2 arguments, resolve and reject. These 2 function arguments decide whether to resolve or reject the promise. When you call resolve, the promise moves to resolve state. When you call reject, the promise moves to rejected state. It is also possible to create a promise that's automatically resolved. Just call promise.resolve with a value. Promises can be passed around as values, as function arguments, and as return values. Values and reasons for rejection can be handled by handlers inside the then method of a promise. Then may be called more than once to register multiple callbacks. The callbacks have a fixed order of execution. Then is chainable, it returns a promise. If any of the arguments are not functions, they have to be ignored. OnFulfilled is called once with the argument of the fulfilled value if it exists. OnRejected can also be called with the argument of the reason why the promise was rejected. Let's see an example. We will use promise.resolve to create a promise payment amount and automatically resolve our promise with a value of 50. Let's describe a then handler. We will use an arrow function to perform some operations on the amount. We will multiply it by 1.25, console log it and return it. This return value is passed as amount in the second then clause. Remember, promise handlers can be chained after each other. We will now create a proper promise and we will reject it after 2 seconds. In the then call, our success handler will be null and our error handler will simply console log the error. Instead of promise.then null error handler, we can also use promise.catch error handler to make error handling more semantic. It is best practice to always use catch for handling errors and place it at the very end of the promise handler chain. The reason is that catch also catches errors thrown inside the resolved handlers. In our third example, we are creating an automatically resolved promise. As P is resolved, the first handler logs its value and the second handler throws an error. This error is caught by the catch method displaying a message. Promise.all takes an iterable object of promises. In this section, we will simply use arrays. Once all of the promises in the iterable are fulfilled, promise.all returns an array of fulfilled values. Once any of the promises in the array fails, promise.all also fails. As you can see, 3 lone promises are described in the code. 2 succeed after a while, and the third one is immediately rejected with bankruptcy. Let's declare a promise.all call with an array of the 3 promises. The success handler would be executed if all the promises were fulfilled. This will not happen in this example. The error handler is executed once any of the promises are rejected. This immediately happens because of the third promise. The output of this code is obviously bankrupt, and it's displayed immediately right after rejecting the third promise. The state of the other 2 promises don't matter. I hope you found promises interesting, especially that you don't need jQuery's deferred object or external promise libraries to implement this important construct from functional programming. The exercises will put everything into a different perspective as you will understand promises on a deeper level. See you in the next video, have fun with the exercises.